So first week's content starts from levels of abstraction. So there are three different levels of abstraction: the physical level, the logical level, and the wave level abstraction. On the physical level, the abstraction is done by using data structures and tables stuff, how it is stored on the physical disk. On the logical level, schemas are used to describe how data is stored in the database and the relationships among the data. And on the view level, it hides a lot of information from the end user and only displays the required information. This is the architecture of database system. So what are schemas and instances? Think of schemas as blueprint for the classes of tables or relations, as we will refer it on the future in the future. And what are instances? If tables are thought of as a class, then instances are objects of that class. So that they are the actual content of the database at a particular point in time. So they are analogous to the value of a variable. So on a particular time, that relation will contain this much information or this information. So what is physical data information? The ability to modify the physical schema without changing the logical schema. So you can change the instance, the data stored in it, but you don't need to change how it is stored or the logic behind it. Now, data models. So basically, a data model describes the tools that are required to store the data, the relationships between the data semantics, and data constraints. In this course, basically, relational model is much more focused. Entity relationship model is just used for database designs these days. There's object-based data model and the document-based as well, new models such as network, hierarchical, etc. So let's start with the most important model, that is the relational model, in which all the data is stored in various tables, and the table basically has columns which are also known as attributes of that data, and then the rows or tuples which are the actual entries of the data. This is a sample instructor table and department table. In this, the ID, name, department name, salary are the attributes, and the entries such as 222 Einstein physics, woo, cards are all rows or tuples. Then there are two types of languages, that is data definition language and data manipulation language. Data definition language basically is used to specify the notation for defining the database schema, the logical schema that we talked about, the blueprint, to define that how a table will be constructed, what will it consist of. That is done using data definition language. It also creates a data dictionary which contains metadata about database schema, its constraints, what is the primary key, and the authorization, that who can authorize what. Then there's data manipulation language. In this, basically the accessing, manipulating means changing, inserting, updating, deleting of the data, that is done using DML. About relational algebra, tuple relational calculus, and domain relational calculus uh, are the types of pure DML, out of which relational algebra will be focused in this course. And commercial, the SQL is the most widely used commercial language which we will learn. So what is SQL? It is sequential query language, and it is the most widely used and commercial language. So one of the most important aspects of DBMS is database design, that how the data would be stored in a database, the logical design, deciding what should be stored, where it should be stored, should it be temporary or persistent, how the data should be linked amongst each other. So let us consider this relation. We can see that this relation has many entries, but there's a problem in this relation, and the main problem is that it has duplicate entries for the same building, and this is called data redundancy, which will be solved later on. So be familiarized with the basic notions, terminologies. Introduce the all of data models and languages, that is DML, DDL, and SQL. Introduce the approaches to database design. Start from what are relations. So the relations are tables which contains columns and rows, where columns specify the attributes and rows specify the tuples. And now let's see what are the types of attributes. Basically, types of attributes are data types, which can be numbers, strings, dates, and null values as well. So for example, this given schema, the number is an alphanumeric string, first name, last name is an alpha string, and DOB is date, whereas other number is 12-digit number. And always remember, the attribute values are normally required to be atomic, that is indivisible, that is that DOB cannot be divided further, it's entirely one attribute. Let's see schema and instance again. A schema is a blueprint, an instance is its implementation. So when we talk about a relation schema, then we are talking about a set which has these many attributes, which is a subset of given sets and cross products. And relations are an order. So one of the most important concept is keys. Let K be the subset of relation R. So K is said to be a key or a super key if values of K are sufficient to identify a unique tuple of each possible relation. So ID and ID name are both super keys of instructor. So in the instructor table, each row can be identified by unique ID. So basically, a key is uniquely unique identifier. A key is said to be a candidate key if K is minimal. That is, ID is said to be a candidate key because it has less number of attributes in it. So one of the candidate keys is further selected as the primary key. So a primary key has main two parameters or constraints, that is, it has to be unique and it cannot be null. So a primary key is like an ideal candidate key. So there can be multiple keys and candidate keys, but there will always be one primary key. So in this database, there can be multiple candidate keys such as just the roll number or first name, last name together, because they are all have unique values if they are considered together. Hence, one of these candidate keys will be selected as a primary key since it has to satisfy uniqueness and not null values. Okay, so we select roll number as primary key for this schema. Now let's see what is a composite key. A composite key, it has more than one attribute to uniquely identify an occurrence. Now, one or more of these attributes which make up the key are not simple keys in their own right. This is an important note. That means that I cannot only make first name as my key because two people can have the same first name or same last name, but two people should not have same set of first name and last name. So that becomes the composite key. What are foreign keys? Foreign keys are primary key in relation R1 which serve as a foreign key in relation R2. So in this way, The foreign key from R2 identifies each tuple in R1 uniquely. Now let's see the concept of compound key. A compound key is more or less like composite key, but here the keys or the attributes which make up the compound key themselves can be a simple key. So for example, roll number and course is a compound key, and roll number itself is a key and course itself is a simple key. Here let's quickly see ID is a primary key, course ID is primary key in the course relation, which serves as a foreign key in the takes relation. Student ID is a primary key in student relation, which serves as a foreign key in again takes relation. And all keys have underline. Now, relational query languages. There are three types as we saw: procedural and non-procedural or declarative paradigms. Procedural is basically like C++, where we COBOL, where we can have procedures that is one after another. The sequence matters, and it discusses how to do something, how to get the output for required input. And declarative is descriptive style, where we say what to do, what we want, but not how to do it. For example, this is the procedure to get the square root of something, and this is the declaration to get it. Now there are pure languages that we discussed: relational algebra, tuple calculus, and domain calculus, which will be discussed later. Now let's understand the basics of relational algebra, which will be later covered on in another video. So when we actually select data from tables, we have to use a set of rules or procedure or sequence of instructions or method to do something that is called the steps. Quickly go over the heart of the database management system, that is the database engine. Database engine mainly consists of three parts, that is the storage manager, query processor, and transaction manager. The storage manager has the basic function of management of physical storage. The query processor does the compiling and interpreting of DDL and DML queries. Transaction manager just manages transaction, and a transaction is a set of operation or group of operation that perform a single logical function. Let's see storage manager. It is basically a program that provides the interface between low level data store, that is the physical device, and the DBMS application. It retrieves or stores data or updates data according to the queries submitted to the system. It interacts with the OS and the file manager, and it does all of this in an efficient manner. It has issues such as access control, file organization, and indexing and hashing. It handles that. Now, query processing. This is the compiling or interpreting phase. This is also done by the compiler usually. And then evaluation is execution of the queries. Here is the architecture. It converts into a relational algebra expression that we will learn in the upcoming part of the video. And it can optimize using the statistical data that we have, that is suppose, and then actually pass it to the evaluation engine for it to be executed on the database. Now let's see, it will substitute equivalent expressions which are known to be faster. We have prior knowledge which statements or queries execute faster than another, and also about algorithms. For example, in a high level language, we can say that a for loop is faster than a while loop. Just like that, it will use faster algorithms, and it will also maintain the cost to run the SQL queries fast. Now, the transaction management system, it actually does the transaction management and maintains the data consistency and integrity. Integrity. The consistency is having no ambiguous data, that is consistent data throughout different tables, references, etc. It also maintains concurrency. Now let's see DBMS users and admins. There are different types of users, such as us. We just use the applications of DBMS and the interface provided to us. The programmers actually are the developers who write those applications. Analysts also use some tools to make sense of data, and admins manage the data and the database system. Let us just quickly see the architecture. Here are the users. This is the query processor, which has a compiler linker, an interpreter, a DML compiler and organizer. It will process the queries from these tools and also convert them to application program object code and give it to the evaluation engine, which will later send it to buffer manager, file manager, authorization, where it will make sure that the given privileges are available or not, and to the transaction manager to keep track of it. And this is all part of the storage manager that we saw. And then it will interpret and implement it on the disk storage in such a way that there will be the data indices for faster access, data dictionary for maintaining the integrity, and statistical data for optimization. There are different architecture influenced by different developers such as Oracle or MySQL, etc. The overview of relational algebra operations. There are 1, 2, 3, 4, 5, 6, 7 operation over select and project are done on relations which have no change in the relation itself. They are just views, and the remaining operations are set based operations, set theory based operations. So you need to have a background of set theory. Let's see them quickly one by one. Select does selects attribute or attributes P from relation suppose R. So it will select the columns. Project will create a window or view from the particular relation with suppose some selection. Then the set union, set difference, set intersection, Cartesian product, and natural join. Let's start with the selection. Selection just selects rows from a given relation R based on a condition. So here we are doing a selection where A equal to B and D greater than 5. This is AND, that is conjunction. This is OR, disjunction, and this is not negation. So we will select the rows where A is equal to B and D is greater than 5. Here D is less than 5, so we will not select that. So there will only be 2 rows. Then there's project operation where we will do selection of columns. We will select column A and column C from given relation R. It is written as this. And in projection, the duplicate entries are merged. Now this is set union. So this relation R, relation S with having common entry, and union is just all entries from both R and S. But the common entries are only taken once. Set difference is everything in set R but not in S. So everything in set R but not in S. So the this portion is not selected. So what do? We just subtract R minus R intersection S. This is R minus S. So everything from R except the intersection. So only two R's. Intersection are the common entries between R and S. So only one row. Also, this is an important note that R intersection S is equal to R minus S. As stated above, if we substitute R minus S is equal to R minus R intersection S, multiplying the negative sign, we get R minus R plus R intersection S. So this gets cancelled and RHS equal to LHS. So a Cartesian product in mathematics is defined as for ordered pairs A comma B and A comma B. Cartesian product is given by AA and AB, A plus BA and BB. Plus means concatenating one after another. So we will take each row from relation R and combine it, that is write together with each row from relation S. So that will be 2 cross 4, which is equal to 8 entries. Here, see, 8 entries. Now, what if the common columns in relation R and relation S? We'll just call the column B from relation R as R dot B and from S dot B. This is object oriented convention. Here, what if we want to do R cross R? We will not be able to identify if they are named as R dot A and R dot A. So what we will do is R cross R, but before that we will use the renaming operator and rename the relation R to S. So there are 2 entries, so 2 cross 2 will be equal to 4 entries. Yeah. Composition of operations means combining operations. Here we are doing select and cross. First we will do cross, that is R cross S, and then select where A equal to C. This is our R cross S, and we will check where A equal to C, and we will take only those entries over here. These are the entries. Now this is one important concept, that is natural join. Remember sentence, that is a natural join is just Cartesian product on all common attributes which are equal, which have equal values. Let us understand by example only. So these are 5 entries. These are 5 entries. The Cartesian product will have 5 into 5, which is equal to 25 entries, and out of which we will see where the column B and D are common in both the relations. So we will see the values where B and D are equal, since that's what a natural join is. And a natural join can be defined by this query. We are projecting or creating a window which shows us these many attributes, which is based on R cross S, and select where R dot B equal to S dot B and R dot D equal to S dot D. So in this way, there won't be 10, sorry, there will be 25 entries, since 5 cross 5 will be 25. There will be 25 as such, and we will select those entries where R dot B equal to S dot B, R dot D equal to S dot D. That is called natural join. So natural join is just Cartesian product on equalizing common attributes. Now let's see the final topic, aggregate operations. In this we will see sum, average, max, mean. The names tell the function obviously. If we select an attribute A from any relation, we can calculate its sum using the sum function. We can find its average using the average function, its maximum value and its minimum value. Let's quickly do a summary. This was the selection operation which has a parameter p and a condition to satisfy, an optional condition to satisfy, that is called a predicate, which will return the tuples which satisfy the condition. A projection is like a view, that is a window. Virtual window. Cartesian product is just set Cartesian product, set union, set difference, and natural join is, as I told before, Cartesian product that have same value on all attributes that have same name, that are common attributes. So that's it for this week, guys. I'll see you in the next video.